Welcome, everyone. Happy Thursday. I think it's the last session of the day before the party.
Yep.
So hopefully you'll enjoy this session. My name's Roland Barcia. I'm the worldwide director in our worldwide specialist organization for serverless, work in our app mod team, helping our customers build, deploy, run cloud-native applications, modern applications, and I'm joined, have the honor to present with Greg. Greg,
So Greg Epple, tech leader for cloud operations. So I cover observability, compliance, governance. I run an internal tech community of about 1,000 folks. And prior to that, I was the observability SA for the organization.
All right, excellent. So I'll kick off, spend about 10 minutes talking a little bit about modern apps and why they're a little bit difficult to do operations, observability for. Greg is going to come up here and kind of talk about some of the best practices, actually show some hands-on examples. So we're really looking forward to that. How many people consider themselves admins here? Let's see. Okay, SREs. Developers? All right. Architects? Security folks? All right. So we got a good mixed bag. I think developers are winning. As a dev guy, it warms my heart to see a lot of developers really concerned about observability. Because oftentimes in the past, it was a day two problem. But we really believe observability is a day zero problem. And we believe modern apps, if built right, are built to be observed. I think Werner said this morning, it's an event-driven world now, right? Everything is asynchronous. And that's the nature of modern applications. And people struggle with observability in applications. Everything from it worked on my laptop, but it didn't work in production, to actually using operations and logs as a source of data to improve your systems. So I'm not going to go through the agenda because we're going to live the agenda, right? But let's get into why modern apps are more difficult to observe. And fairly simplistic, in the past, in my previous history, I used to build J2EE applications or Java EE applications, and they were monolithic applications. And monolithic applications are probably easier to operate, right? You have one big application that you've built operations around. You probably had a single programming language, a single platform, tools designed around that platform. It's easy to monitor one thing, right? There might be a lot of things inside of that thing that have built up over years, and there's difficulties and challenges there. But in modern apps, we've gotten more and more distributed, right? We're building applications with all sorts of various types of technologies. We're building microservices, cloud-native apps, different deployment models like Lambda functions, containers, ECS, EKS, ROSA even. So tons and tons of services, and you're building lots of little applications that are communicating with each other, maybe across availability zones, across regions, all these various different technologies. And so when we get to microservices, right, microservices have a lot of different characteristics, and this is an ever-changing list, so loosely coupled. Right? You have microservice-based applications that are calling each other via APIs. If you start building event-driven applications, you have things in between like topics, queues, event bridge, event routers, streams, and you're chaining types of events down system, right? So lots of communication. How many people struggle with downstream observability across components? Let's see, one here. Yeah, big struggle. The other thing is we say it's stateless. The truth of the matter is there's state in systems everywhere. It's how state is handled. Right? We don't want them to be handled, although now, even with modern apps, we're seeing people use things like containers and Lambda to build AI/ML pipelines and stateful type of use cases as well. So that's interesting. Polyglot, lots of different programming languages. We'd love everyone to be a full-stack developer and develop everything in the same language, maybe even use something like CDK in my same programming language. But the reality is you have front-end applications maybe in JavaScript and TypeScript using frameworks like React. A bunch of stuff in the browser might be happening calling APIs. Those APIs could be in Java. You can call something downstream, and it's an AI ML pipeline thing in Python. So you're dealing with more programming languages. If you're doing asynchronous development, you're losing context along the way, right? You might begin a context from one event to another event, et cetera. Different types of hosting platforms, depending on the types of applications you're building, I'll get into that. You might be deploying functions in Lambda. You could also be deploying containers using things like ECS or EKS or ROSA. So you're hosted in different environments. You have things like networks in between these things, right? So you might have a Lambda function calling out across VPCs, out to another VPC calling something in a container, and you have layers within there. You have clusters, et cetera. All different types of things. All these tools, people use microservices because they want to move faster. They want independent pipelines. So advantageous for developers to remove their dependencies and leave all the headache for the operations teams downstreams, right? To kind of assemble these things, et cetera. More emphasis on independent DevOps pipelines. More independence on scaling. You have some components that might scale up to thousands of pods, calling something that's a singleton, calling something that's scaled independently. So now you have to track, not just the application layers, but what availability zone, or what region, or what cluster, or where did my request go? If you're using things like service meshes, like an Istio, or things like that, you have sidecars and things inside of applications that get added by environment. So all these things create issues that make it hard to monitor these applications. And monitor is a traditional word, right? But in reality, what we want to get to is, how do we deal with this complexity? Because we're moving in this direction for a reason, right? We want to be more agile. We want to move faster. We want to deploy apps. We want our business to function quickly. But at the same time, we want to make sure that the intention of microservices has always been to build observable applications. If you think of observability from day zero, building applications that are built to manage or observable, right, that becomes part of your process, and it makes it a lot easier to do that. And so, for example, right, it shouldn't be this big, giant, complex headache, but observability is, to me, I'm not going to read the definition, but it's really a full life cycle, right, of really thinking about the way you deal with logs in your system, metrics in your system, how you deal with tracing in your system, really treating them like first-class citizens as part of your system, and having a full life cycle around it. Being able to troubleshoot problems, right, and resolve things quickly, right, will make sure you don't lose money, right? Every time you have a problem in production, you don't solve it, et cetera. How many people here write bug-free code? How many developers? I got one. All right. How many people have gotten bugs into production? Absolutely, right? Things fail all the time. Well, I'm going to see a quote in a minute. But rather than kind of, thinking about, of course, app-mod domains include things like DevOps, security, et cetera, right? Thinking about observability from day one, how I'm going to troubleshoot things are key, right? And so, Werner says, everything fails all the time. It's a law of thermodynamics, entropy, right? Everything, as it runs down, right? Things run down over time. Developers love to build something new and love to say, here, junior developer, take over the cool thing that I wrote. I'm going to go build the next thing, and you should maintain what I build, right? That's like the nature of a developer. And so let's leave them with observable code, right? One last point I want to make when we talk about modern apps, a little bit on the developer side, is primarily in my world, the developer world, right? We've seen two strategies when it comes to app mod, and customers having a lot of success with both. I talk about this because we talk about modern apps. We in AWS want to make sure we got you covered on both sides. So we have our AWS serverless approach, serverless first, right? And really that's the notion of really looking at AWS and using the tools around AWS and consuming as many managed services as possible. Using technologies like Lambda and Fargate to write systems, using AWS VPCs, networking, security, using infrastructure as code tools like CloudFormation, CDK, and using as much managed services as possible. So technology like Lambda, AppRunner, ECS, Fargate, all these technologies really enable you, especially for teams and companies that don't have large platform central teams. We have other sets of customers that have gone all in as Kubernetes as their primary compute platform for all sorts of reasons, right? Whether they want a consistent platform between their on-prem and their primary cloud, they're deploying to different clouds, or the ecosystem around Kubernetes. We have managed Kubernetes EKS. We also have ROSA, managed OpenShift in a partnership with Red Hat. We have various ways. Over 60% in the CNCF did a survey in 2022, over 60% still Kubernetes workloads run in AWS, in the cloud. So what does this have to do with observability? Well, depending on the strategy, we have customers that have different observability stacks. So when we think about AWS serverless approach, native approach, and you can use different stacks across the board, meaning you can use AWS native services with Kubernetes or vice versa. But the goal here is we have a set of managed services and an observability stack, and we also support the various popular open source tools in managed format, things like managed Prometheus and managed Grafana, as well as work with partners if you're doing this with EKS. So a lot of these best practices would apply across the board. Greg is going to focus on the native side, right? Serverless first with a lot of his demos, et cetera. But there's other sessions that have happened this week, and you can see in the recording that talk about, hey, if you're doing EKS or Kubernetes. How many people here are using Lambda? Let's see. Fargate, ECS, EKS. Anyone using ROSA? All right, so got one over there. Awesome. So you're going to hear a lot of great best practices. So with that, I'm going to turn it over to my buddy here, Greg. All right.
Can you guys hear me okay? Good. Awesome. Thanks, Roland. So yeah, I'm going to cover 4 best practices. This is really me distilling down. I've talked to hundreds of customers over the last few years around observability, and I've largely have taken all those customer conversations and we've distilled them down to these 4 best practices. So the first one's going to be navigating your instrumentation options. There's lots of options out there in terms of how do you instrument. I'll talk about what we'll do for you and what you'll need to do as a customer when it comes to instrumentation. One thing that's really challenging in modern workloads is there's a lot more metrics and logs, and that can lead to high cost. So I'll talk about, as the second best practice, how you optimize the cost of high cardinality. After that, we'll talk, because there's lots of metrics, that also potentially means there could be a lot of alarms going off, and we'll talk about how we can reduce some alarm fatigue as well. And the last but not least, and probably the most important, most misunderstood, is how do you avoid dangling traces? How do you get that end-to-end trace in your application? So let's start with navigating your instrumentation options. Instrumentation on AWS is a shared responsibility. We will send a lot of metrics and logs, especially metrics, from our services to CloudWatch. But you shouldn't stop there. You need to take on some of the responsibility to do instrumentation. I'll kind of walk through our best practices on how you should think about the metrics and the logs and the traces we send and what you guys should be doing in your applications. But I can't stress this enough. This is a shared responsibility between us. But let's talk about AWS first. This is a vended metric. It shouldn't be a surprise to anyone. This is Lambda. It's a number of invocations. It sounds simple. Don't make any assumptions about what this metric means. There's a fantastic, and you probably want to take a picture of this QR code. There is a page in the documentation in all our docs that links to every single service that sends a CloudWatch metric to AWS CloudWatch. If you're starting to use a new service, whether it be Kinesis video streams, Cognito, API Gateway, I cannot stress enough, you need to go look at those metrics. Go to this page, bookmark this page, and when you go to use another service, understand what we're sending to CloudWatch for you. So let's take this is just an example of a Lambda, the link to the Lambda docs. And so if we click through, this is the Lambda docs. There's a few things you're going to notice in every single service in terms of our documentation. First, we're going to tell you what statistics are available. Not every statistic is available for every service and every metric. So in this case, this is a sum statistic, so the number of Lambda invocations. For other metrics, there may be percentiles, there may be averages. The documentation will explain which ones you should be looking at, how you should interpret that data. The second piece that you'll find in our documentation around our metrics is English explanation of what that metric's measuring. Again, you make assumptions on a lot of this stuff. Try not to. Read through the docs, really trying to understand. There's a lot of rich material here. And third, last but not least, is the dimensionality. A lot of our services will send that metric across different dimensions. So for example, we have our synthetic testing service. We can set up a synthetic canary. We're going to send a duration metric for that canary. That canary can also have steps within your test, and we'll send a duration for each of the individual steps. So it's really important to understand the dimensionality of these metrics. Let's talk about logs. This is just an example of logs. There's a lot of services that send logs into CloudWatch. Some services will send logs into S3. Again, you largely, when you use services like Lambda, you don't need to do anything initially. We will send those metrics and logs automatically for you. And then some services like X-Ray, like some services like Lambda, to enable tracing, it's simply a checkbox or a toggle. In this case, it's a toggle. You go into your Lambda function, you say, I want to enable X-Ray, and that will start to capture, or will start to vend traces every time that Lambda function executes. API gateway is very similar. And we'll talk more about the trace propagation layer. But let's talk about what you need to do here as well, because this is a shared responsibility. And I'm going to start, first of all, with serverless, more specifically Lambda, and then we'll talk about containers in terms of instrumentation. So instrumentation in Lambda is fairly straightforward. This is an example of a log, right? There's a console object in the Lambda function. We can log different types of logs, log, info, warning. Again, very simple to get started. You basically just use this object and start logging. Just three examples of me sending different type of logs to CloudWatch. Now, in terms of metrics, how do you send a metric to CloudWatch? There's a few different ways. You can call our put metric data API. I wouldn't recommend that, because that is introducing a synchronous call to our API. The more efficient way, and I'll dive deeper into this when we talk about high cardinality, is to use something called embedded metric format. So this is just an example of me bringing in that namespace, applying some dimensions, putting in a metric, and also setting some properties. I'll talk more about how that works later on in the presentation. And then we'll talk about traces from a Lambda perspective. So like I said, it's a checkbox to get Lambda to instrument itself for tracing, to show up in X-ray. If that Lambda function needs to go do something, put an item in an S3 bucket, call another Lambda function, there is some instrumentation that you'll need to do, and this is just an example of that. I'm using the X-Ray SDK, and then wrapping my call to S3 in that. And this would further propagate that trace downstream. So again, Lambda, fairly straightforward. Serverless, fairly straightforward. Let's talk about containers. What about containers? There's a lot of options out there. And what you'll see, I put together this little table of your different options for logs, metrics, and traces. The one thing you'll notice is there's no one solution out there that does all three currently, right? We have the AWS distro for OpenTelemetry that collects metrics and traces. We have the CloudWatch, but doesn't do logs. The CloudWatch agent collects logs and metrics, but doesn't collect traces. We have things like FluentBit, FireLens. Those are simply collecting logs. They have nothing to do with metrics and traces. So right now, there's nothing that covers all three of these signals. And we'll talk more about my recommendation on how you should think about this in moving forward with choosing an instrumentation agent. But overall, I would say start with OpenTelemetry and then pick what works in terms of logs. And if you're not familiar with OpenTelemetry, it's basically an open standard to collect observability signals, the metrics, logs, and traces. So metrics and traces right now are GA. Logs are not. They're in a draft status for the specification. So currently, you can't, in a GA sense, collect logs right now for OpenTelemetry. But the idea of OpenTelemetry is just to basically unify the collection of these signals, right? You have your application. You do some level of manual or auto instrumentation, right? So you're pulling, for example, system logs, infrastructure metrics off your containers. You have your app logs. You're doing tracing. You have application metrics that you're vending. And the idea is that all three of these signal types come to an OpenTelemetry collector. Again, like I referenced on the previous slide, we have our own version of the collector. It's called AWS, or what we call ADOT, the AWS a distro for OpenTelemetry. And that collector sits there and just consumes these signals in an open format or standard format. There's an optional enrichment process. So as you bring in your logs, metrics, and traces, you can enrich those signals. And then you can export this. And this is where the power of OpenTelemetry is really, really great, is you can export this to multiple locations. You can export this, for example, to X-Ray or Jaeger or Zipkin. So you don't have to choose, you don't have to use a proprietary language to collect this information. You can collect it once and send it to multiple places. And then the idea is that because you have one central place that's collecting all three of these signals, we can do correlation. So the first best practice, just the takeaways here, and then we'll move on to the next one. Start with OpenTelemetry for your metrics and traces. If you choose to use our distro, it's supported by AWS support. You don't have to. You can use other distributions. That's fine. But start with OpenTelemetry. Then choose a logging agent, right? Use FireLens, FluentBit, CloudWatch, but pick what works for you and your workload. And like I mentioned previously, the OpenTelemetry specification, at some point, hopefully, fingers crossed in 2023, we will see logs go GA. And at that point in the future, when we do have logs as GA as a specification, then use OpenTelemetry for all three. All right, so let's talk about the second best practice, optimizing the cost of high cardinality. I'll explain what high cardinality is if you're not familiar with this, but here's just some metrics I put together. We have a latency metric, right? This is measuring latency of something. We have dimensions. So we have three different dimensions. We have our request ID, customer ID, and service. So we have a few services here, put item, list item, get item. Those first two columns are potential examples of high cardinality, and I'll explain why, and the implications of high cardinality. So let's take a metric like HTTP response. Maybe this measures latency. So here's a single metric. Let's say we have two dimensions. So we have status code. There's only 5 status codes, 1, 200, 300, 400, 500. And we have environment. So we have dev and prod. The cardinality of this is a lot, just from these two. There's one metric with these two dimensions with a few values. But let's apply this and then scale this out. Let's think about your more traditional monolith. You'd have a VM environment. Maybe you're running on EC2, maybe you're running on-prem, it doesn't really matter. But your typical monolith, you're probably still going to have a dev and a prod, I would hope. Maybe we only have 10, we're starting on that microservice journey, and we have 10 different services. We still have 5 status codes, that doesn't change. And maybe we're load balancing this off of 10 instances. So how many metrics is this? It's about 1,000 potential metrics. Once you take all those different values, you could potentially have 1,000 different metrics. Now let's shift to a more modern architecture, right? So same metric, HTTP response, we're measuring latency. We still have 2 environments, dev and prod. Now we have 100 services, right? We're starting to break down that monolith, and we have more microservices. We still only have 5 status codes, but maybe these services now are super ephemeral, and they're tasks or pods or whatever container system you're using, but we have about 10,000, let's just call them pods. We're using EKS. We have 10,000 pods. How many metrics is this? This is 10 million potential metrics. So we've gone from 1,000 potential metrics in our monolith to over 10 million in this fictitious example of moving to a modern architecture. Does anyone want to guess what this costs? So if you look at the public pricing in US East 1 for CloudWatch metrics, 1,000 metrics will cost you about $300 a month. Now, as you use more and more metrics, the price per metric gets cheaper. But 10 million metrics would cost just shy of $250,000 a month. And this is not specific to CloudWatch. If you look at other vendors, metric solutions, metrics just cost a lot of money. Different people will charge different ways, but the end result is if you're going to send a lot of metrics, you're going to pay for it. So I work with a lot of customers, and customers that have hundreds of millions of metrics. And traditionally, there's been this trade-off that you had to make. You could pay that cost and store all that as a metric. But what are you going to do with 10 million metrics? You can't graph it. You certainly are not going to alarm on that many metrics. But if you choose to go with logs, yes, it's going to be more cost efficient, but logs inherently are slower than metrics. So a lot of customers I worked with had to choose between these, but my recommendation here is use both. Again, as Roland said, I'm going to approach this from a CloudWatch and AWS native perspective, but this principle would apply to any type of workload. You could do this yourself. It just so happens we provide a feature for this called CloudWatch Embedded Metric Format. And in fact, OpenTelemetry collector actually has an ability to send your metric data through this feature into CloudWatch. So let's just imagine, I'll go to a demo here in a second, but let's pretend we have a piece of telemetry here. So you're going to see 3 colors, right? In green, I have my dimensions. In pink or salmon or whatever you want to call that color, that's our potential high cardinality. And then blue or aqua, we have our metric. So we'd take this telemetry that we're pulling off systems and applications and servers, and we could combine this as a log first, and then we'd choose what to actually create a metric of. We don't need to create a metric for every single pod and task ID. Let's aggregate those metrics, only create aggregated metrics, and this can lead to huge cost savings. So I'm going to switch to my demo and walk you through a little bit what this looks like. All right. And my laptop's asleep, so bear with me 1 second. Okay. So we're over on my demo environment. Now, I apologize, I'm a .NET developer. So all my demos are going to be in .NET. But this is just an example. I just created a little application to create a lot of metrics basically every few minutes. But this is basically how you would create this manually if you want to send some metrics through CloudWatch Embed Metric Format. So I'm basically going and creating dimension sets. I'm saying, what type of dimensions do I want to use? So I have a dimension that is going to vend basically 2 metrics, and that first dimension set is going to be the service name, the status code, and environment. I have a second dimension set, which is going to be just the service and environment, and then a third, which is just the service. And so I apply those dimension sets. I then put my metrics here, so I'm just generating some random numbers, but I have 2 metrics I made up, processing latency and processed records. And then there's some examples of some high cardinality data. So for example, request ID, maybe this is good. You should never ever put a good as a dimension in a metric. Or say a task ID, if you're dealing with tens and hundreds of thousands of tasks. So this is currently running in the background. I'll show you what this looks like in CloudWatch. So if we go over to CloudWatch here, I'll just go to my first page. So all this telemetry comes in as a log first. And I'm going to go ahead and run this code. I'll just show you an example of what this actually looks like when it lands in CloudWatch. But here's an example, basically, of that telemetry. So we have our processing latency, our records, we have these dimensions, as well as these high cardinality properties, basically. And then there's a specification for embedding your metrics in the logs here, and we're basically defining how should this land as a metric. So we're not going to create a metric per task ID. We're going to create a metric based off these aggregated dimensions here. So I'll show you how that looks as a metric. And so this is just my namespace in CloudWatch, the AWS embedded metrics. So I only have about 104 metrics here, so you can see those dimension sets, right? So I can see my environment and my service. So I have 4 services: a cart service, a search service, a payment service, an order service. And I have this separated by environment, or maybe I just want to look at the services across all environments. But the idea here is that I'm not creating tens of thousands of metrics. I'm only creating aggregate metrics, things I would want to put in a dashboard, I would want to drive alarms with. But the beauty of this is still all available as a log. And if you do need to do some sort of aggregation, you can still do that as a log. I'll just go back to log insights here. But I can go ahead and all that telemetry is still available for me to run my queries to do aggregation. It's going to be a bit slower because it's a log, but it's still there. So CloudWatch embedded metric format basically gives you the best of both worlds. Again, if you're not using CloudWatch, that's fine. You can still apply this pattern elsewhere. So let me go back to my deck. So our second best practice, just some takeaways here. Identify potential high cardinality dimensions. I'll give you an example. This is we could talk about this publicly because I did a blog post. I worked with British Telecom. And in this blog post, if you go search online, you'll see they use this feature, but they have millions of devices across the United Kingdom that basically provide, they're called smart home hubs. They send a bunch of telemetry every 5 minutes. Let's call it 20 pieces of telemetry. So a million devices times 20 metrics, that's 20 million metrics. And so they use the CloudWatch embedded metric format to basically bring in 20 million metrics every few minutes into CloudWatch. And it only created about 2,000 metrics on the aggregation points that made sense for the business. How much jitter is coming off this device in all of England, for example, or Wales, or the whole of the United Kingdom, or maybe I just want to look at Belfast, for example. So they were just an example of a customer using this at scale. So again, identify those high cardinality dimensions, ingest your telemetry as a log first, and then create metrics using the appropriate dimensions, the aggregated dimensions that make sense for your business. If you're using CloudWatch, you can leverage this feature I just showed you. If you're not, that's fine. But if you are, and you're using OpenTelemetry, we will send the metrics automatically for you using basically this technology. All right, let's move on to our third best practice, reducing alarm fatigue. No surprise, I think everyone in this room would agree, metrics usually drive alarms. Well, we just finished talking about high cardinality telemetry, and even in a monolith, it's really easy to get alarm fatigue, right? There's a lot of metrics. We moved to modern architecture, we have a lot more metrics we have to deal with. And so you can imagine the types of alarms that would be going off. I've been there, I've been in an ops role. When alarms are going off, I'm wondering what the heck is happening. This is usually the look I have. I would say it's a look of fear, confusion, like what the heck do I do next? But alarm fatigue is a really big problem with observability. So the first thing I would say is really think about what you need to alarm on, right? Alarm on key performance indicators and workload metrics. So this could be order rate. You can imagine a very high volume e-commerce website might really care about how many orders are going through a second, or the number of orders processed. Or if you're building like event-driven architectures, what's the queue depth on your SQS queue, for example? So think of these important metrics, things that will tell you that something's gone wrong and it's affecting the user. Alert when those workload outcomes are at risk. And a lot of this stuff should sound familiar if you have read the operational excellence pillar and well architected. Alert when workload anomalies are detected. And automate responses to events as much as possible. Correlation is really important, right? If we think back, I'll use my .NET background, Windows web servers, right? So let's go back and think about those monolithic apps, right? High CPU is not a great alarm. Please don't ever alarm on high CPU. It does not tell you if the user's having a bad experience. Memory utilization alone may not be a good alarm either. However, both are happening at the same time. Let's say CPU is going up to 100% and memory has just dropped off a cliff In a Windows workload with IIS, this is a very bad thing for users because what's basically happening is an application pool is recycling, all requests are being stopped, and the CPU is going high. So if you can measure these two things or correlate two alarms at the same time, and then alarm on that, this is very powerful. So like I said, this pauses the HTTP request pipeline for Microsoft IIS web server, and the users are going to know this. So as much as possible, again, it's really hard sometimes to figure out what you should correlate, and sometimes, unfortunately, you have to go through these operational events and learn from them, but don't take that as that's an opportunity to learn and to improve your alarm posture. Other best practices around alarms is leverage statistical and machine learning algorithms as much as possible. You want to generate an anomaly detection model to show you an expected range. Alarm on a dynamic threshold, not a static threshold, and I'll show you why in a few slides or in my demo. And there may be valid reasons for spikes and dips in your metrics, right? You don't want false positives, so machine learning can really help with this. They can make your alarms more intelligent. Again, because I'm approaching this from a cloud native or AWS native perspective, I'm going to show you two features in CloudWatch that will help you with this, but you want to keep these patterns and principles in mind. Doesn't matter which observability solution you're looking at. So I'm going to switch back to my demo. All right. So one of the most powerful and easiest things you can do to get started on creating better alarms, do synthetic testing. It doesn't have to be CloudWatch, that's just what I'm showing, but you want a synthetic test. Synthetic testing and synthetic monitoring will give you a representative understanding of what an actual user is experiencing. So I just have a little test here, a little what we call canary. We call this synthetic canaries. And this runs every single minute. I just started this a few hours ago. And so every time this thing runs, it's going to create a metric. It's going to create a bunch of metrics, actually. If I go over here, I'm going to get an average duration. So this, when I hit this site, which is a very slow site, it takes just under 20 seconds to execute. And you can see how that ebbs and flows throughout the day there. But this is a fantastic metric to alarm on because it's measuring, it should be measuring what a normal user is going to experience. And it's really easy to get started with this. All you simply do is go to synthetic canaries, create canary. If you're familiar with Selenium or Puppeteer, both those are supported. A synthetic canary is effectively a Lambda layer running a headless Chrome browser. And so you can use Selenium or you can use Puppeteer. If you don't know either of those, we have a web recorder in the Chrome store. So you can just go ahead and start clicking on a page and generate a script and then paste it into a canary and get started right away. We also have blueprints. If you just want to heartbeat something, I want to go to this page, take a screenshot, ensure I got a 200 response back, you can do that. So again, if you're trying to figure out what should I alarm on, if you don't have synthetic testing and monitoring, start with this. And I mentioned machine learning and anomaly detection. This is a really good example of that. I have a traffic generator this metric here is orders processed. And so it's sending a metric value, and then every hour it's going to dip. Right? Imagine like an e-commerce site, right? The orders, maybe you're not global, you're just focused on, let's say, the US. You're probably going to see an ebb and flow, right? Yeah, there are people up at 3 a.m. ordering things off your website, but most of the traffic comes during the day. So when you're using static thresholds, this is really hard to alarm on, right? Like because you can't, you have to accommodate for these dips, and you're going to constantly get false positives because this is expected behavior. So when you turn on anomaly detection, it will learn what normal looks like. It will say, hey, there's a pattern here, and I've seen this before, and you know what? I think this is not something we actually should alarm on. So once you enable anomaly detection on a metric, you can go create an alarm. And as opposed to saying a static threshold, which is very difficult to maintain, you can simply say, I want an alarm when this goes outside of that band, and you can make the band narrower and wider using a parameter for standard deviation. Or you can say just when it goes above or just below, right? Maybe orders processed, that's a good thing when it goes high, right? You just want to alarm when it goes low, there's something wrong. The other thing I talked about was correlation, and this is also really important. So think about the metrics that you can alarm on, and look at the things that if let's say these three things happen, and they all happen at the same time, that's what I want to alarm. If you can capture that in CloudWatch and in many other systems, you can correlate those alarms. So what I have here is an example of that, basically. I have a metric for 4 of my services I showed you earlier, right? The order service, the payment service, search, and cart. Those all have alarms. They're all alarms, but they're not sending anything to anyone. They're just there to either pass or fail. And then I have some Boolean logic, if I go to my alarm rule here, that will say, this compass alarm only alarm when all 4 of these alarms are in a bad state. So this helps you reduce the alarm fatigue because you're minimizing the amount of potential things to notify folks, and you're also making this more intelligent. And you can have a composite of composites. I believe it's up to 1,500. So you can get quite like an extensive alarm tree there within CloudWatch. So just an example of this. We can see our synthetic canary here as well. And here's my alarm, my composite alarm, called all services down. This thing should be waking up the CTO. If everything's broken, something's gone horribly wrong. All right, so go back to my deck, and we'll go on to the last best practice here. In summary. So alarm on KPIs and workload metrics. Alarm when your workload outcomes are at risk. CloudWatch Synthetic Canaries is a really good way to do this because it's simulating the user. Correlate your alarms and notify a person when that correlation happens. You can still have a lot of alarms, just make sure those alarms inside the composite aren't also paging people. And then leverage machine learning algorithms to detect anomalies. So between these 3 features in CloudWatch, we have the ability to help you reduce alarm fatigue. Oh, and it looks like, sorry, some pictures will be taken. And all of this will be online afterwards in a few days on YouTube. All right, last best practice, my favorite. Avoiding dangling traces. This really confuses people. It confuses me. It's really hard to understand how tracing works. But let's talk about what tracing is, first of all. So here's an X-ray trace ID. It has 3 components. Basically in our systems, if you look at the request or the environmental variable, the trace ID is described this way. The first component is the root. So this is the trace ID. This is the ID that ties everything together. We have the parent, which is optional. So if you're starting a trace and you don't have anything upstream, the parent's going to be empty. And then you have a sampling decision. But if you deconstruct what an X-ray trace is, this is basically what it looks like. And then there's these 3 components. So let's imagine, or how does this actually work, right? We have API gateway, classic example, talks to Lambda function. That Lambda function puts an item in an S3 bucket. The trace, the ideal trace is something that captures all 3 of these things, right? So each of these steps, you'll see these as circles, for example, in CloudWatch Service Lens. I use the OpenTelemetry term as span. We use segment with an X-ray, but I'll use the OpenTelemetry term. So we have our span. We have our trace ID. Trace ID is 1, 2, 3. Now that first span, this is what starts the whole trace, the API gateway. Let's say that span ID is ABC. So API gateway is talking to Lambda. Again, with Lambda or API gateway to Lambda, you don't have to do anything. You just basically toggle a setting. But there's a trace context that's passed to Lambda. That trace context contains the trace ID, 1, 2, 3, and contains upstream parent, ABC. Lambda receives that context. It generates its own span ID or segment ID, DEF. And then that context is then passed further downstream. So the trace ID remains the same, 1, 2, 3. But the parent is different because the parent is coming from, or when this gets passed to S3, it's a different parent. So let's take a slightly different example. Let's pretend we have an ECS Fargate container. It's putting something onto Amazon MQ, RabbitMQ, let's say. Now, ECS, we've instrumented our container. So with X-ray or OpenTelemetry, so it's generated the trace ID, it's generated a span, it's passing it down to, or there's nothing in RabbitMQ that knows anything about OpenTelemetry or tracing. So nothing is actually sent there. And then say we have another ECS Fargate container and it's pulling something off the queue. Well, there's no context for it to pull off. So what this will end up doing is you'll have a dangling trace. You're going to see Lambda to, you'll just see basically two Lambdas and they won't be connected whatsoever. So this is a dangling trace problem. All right, and I'll come back to it in a second, but how do we get started with tracing? If all you're using is containers, this is fairly simple. As long as your language is supported, just install an OpenTelemetry agent, use the SDKs, that's all you need to do. Unfortunately, with cloud native services, the answer is really, it depends. So bookmark this page, first of all. This will take you to the X-ray documentation. These are some of the services that we support, that natively support tracing. And I'm going to talk about a few of them quickly, then we'll do a demo and then wrap up. Elastic load balancing supports X-ray. A lot of people actually don't know this. You're not going to see an ALB on a trace map, but when an ALB is handling a request, if it detects a trace ID, it will pass it downstream. If it doesn't, it's going to generate a new one. So ALBs support tracing. Lambda. We already talked about this. Enabling Lambda, X-ray and Lambda means traces, when that Lambda function executes, automatically get sent. However, instrumentation is required for anything you do further downstream, calling S3 bucket, putting something in an API, calling a SQL server, like a relational database. And then in some cases, like Amazon MSK or Amazon MQ, X-ray tracing is not supported. And it's not because we can't do that. Those are open source projects, right? They don't know anything about X-ray. EventBridge, we actually just recently, maybe a few weeks or a few months ago, EventBridge supports tracing, right? However, you need to read the documentation, understand that it will support tracing only if the event came from a put event. So if you're using EventBridge to put a message and to the route that somewhere else. Step Functions is supported for step functions that call SNS, SQS, Lambda. It's going to work natively without you having to do anything. If you have step functions that are interacting with batch, Fargate, or ECS, you will have to do some instrumentation. So the point here is look at the documentation, understand what's supported and what's not. So let's go back to this example. I don't actually have, I have console apps I've written, so we'll pretend those are Fargate tasks. All right. So I'm going to go, you'll just have to take my word for it. This is a .NET app. This pretends running a Fargate container. It is going to go put a message, hello world, onto, I have an Amazon MQ cluster stood up running RabbitMQ, and this is going to go put a message basically on that. So I'm going to just run this once. So let this run, and I'll go and show you in X-ray what this looks like. So if I go to X-ray, and I would just need to, Oregon is the right one. Just bear with me, it'll take a second to show up. Okay, I just had to, sorry, bear with me 1 second. I have my OpenTelemetry collector, and I just really have to rerun that. So let's try this one more time. All right, so we'll go through here. I'm just executing, I'm putting the thing onto the queue. All right, something's gone wrong here, but I have a backup, so I can show you basically what this will look like. So we have a trace. If that code was working, what you would basically see is you would see a trace here with the publisher service. So I have a publisher and a consumer service and a RabbitMQ cluster in the middle. And so basically what you would see is that application, you see this breakdown. So the publisher, okay, it's doing some work, and then it calls RabbitMQ. So we get basically that breakdown. Now if I go back to my code, on the other side of this, I have another service pulling things off this queue. And this is also instrumented. So if I go ahead and run this, what you're going to find when this runs and gets captured is you're going to see basically a map that looks like this. There's no connection upstream to the RabbitMQ to that producer service, right? Because there was no context passed across that service boundary. So you have to understand what services are going to pass that automatically, which ones won't. And in the case that they won't, because they're incapable or they just don't know about X-ray, you need to add that context to the header, pass it across the service boundary, and then resume that context. And so that's basically what I've done in my consumer app. If we scroll down here, what you'll see is, again, if you're not familiar with .NET and RabbitMQ, but there's this properties here, this basic properties. This is coming from the messages I'm putting on the RabbitMQ. And on the producer service, I've injected my trace ID. So I've injected the trace context. And then I have a function here that basically extracts that context, that trace context, from the attribute I added to my message in the queue. And then if I were to change my code here to start a new span, basically, and use that parent context, what you would end up with is a complete trace, right? So I could choose to create a third circle in here that represents RabbitMQ, but the point is I have two services. We'll pretend they were Fargate tasks. One is putting the thing onto a queue, RabbitMQ, the other is taking it off. And because I passed that context, the trace context, across that service boundary and resume the context, I get a complete trace. All right, so I'm going to go back to my deck. I did the demo. So just as fourth best practice, wrapping this up, instrument all your code. You need to instrument all your code with tracing. Understand which AWS services support tracing and how they support tracing. You need to, I wish there was an easy button, but please, you need to understand how these traces work with our services, or how services work with tracing. If a service doesn't support tracing like I just showed you, again, RabbitMQ, open source solution, has no context of X-ray, you need to pass that trace context across that service boundary. And then on the other end of it downstream, you need to resume the context. And that will give you a complete trace, and that's going to help you avoid the dangling traces. So just to wrap this up, we talked about 4 best practices. Navigate your instrumentation options. Overall, the summary takeaway from this is start with OpenTelemetry for your instrumentation. Choose something else for logs. And then once logs is gone GA within OpenTelemetry, then you can use that for all 3 signals. For optimizing the cost of high cardinality, which again is a huge problem as you build modern apps, we generate more data, more metrics. Leverage both metrics and logs. Do not just send everything as a metric. That can get very expensive very quickly. So find that balance. Reducing alarm fatigue, correlate. Correlate your alarms on high-level metrics and use anomaly detection. And last but not least, avoid dangling traces. Ensure trace propagation. So as you look at the different services in your architecture diagram, understand how those traces are going to get propagated across the system. So just some takeaways. We have a really popular workshop for observability that basically will deploy a fully functioning app with a traffic generator in it. There is some cost to writing that, so be careful with that. But we've translated this into 5 different languages. It gets hundreds of thousands of views. It's very popular. I do a lot of my demos off this. Link to the AWS distro for OpenTelemetry. So we have a GitHub page. You can learn more about OpenTelemetry there. And we just published a new skill builder on our training and certification site for observability. So with that, I want to thank you. Thank you, Roland, for presenting with me. I appreciate everyone showing up here on a Thursday afternoon. Go enjoy replay. Thank you.